Welcome back, Physical Science 20. So this is part 2 in the FC2.2 molar mass. So as we saw, the molar mass of carbon and the mass of one atom of carbon have the same value on the periodic table. So this 12 here that we see on the periodic table, this 12 can represent units, atomic mass units when relating to each other. So carbon atom is 12 times bigger than a hydrogen. But it could also represent the amount of grams in a mole of carbon atoms. So if I took 6.02 times 10 to the 23rd carbons, threw them on balance, it would read 12.011 grams. So of course, remember that 12.01 grams per mole and 12.01 units represent different quantities, but the numbers are the same. So 1 mole of or 12 grams of carbon contains this many atoms, so enough to fill 1/4 of a small test tube. That's how much a mole of carbon would actually look like. A mole of carbon atoms fills up a small test tube. However, 12.01 units is the mass of a carbon atom, which is too small to be visible even with the most powerful technology. So if we look at molar masses of compounds, we can also describe quantities of molecular and ionic compounds using moles. The molar mass of a compound is the sum of the molar masses of each entity in that compound. So for example, solid carbon dioxide consists of vast numbers of CO2 molecules. Each molecule contains 1 carbon atom bonded to 2 oxygens. Sodium chloride is a common ionic compound. A crystal of sodium chloride does not contain molecules. They have alternating positive and negative chloride ions, but we call that as a formula unit. So 1 sodium and 1 chloride represents a formula unit. So if we look over here, so to figure out the molar mass of these, it's quite simple, just similar to what we did earlier there. So if I had the molar mass of H3PO4, so I know if I have a mole of this, I have 6.02 times 10 to the 23rd molecules. So this is considered molecules because they're all nonmetals. So even though hydrogen's from the left-hand side, it's considered to be a nonmetal. So if I have for every 1 mole of this, I have 3 moles of hydrogen, 1 mole of phosphorus, and 4 moles of oxygen, as we can see here. So 3, 1, and 4. So hydrogen is 1.01. Phosphorus is 30.97, and oxygen is 16. So 3.03, 30.97, and 64. So that gives me a grand total of 98.0 grams per mole of H3PO4. So if I had a mole of H3PO4 molecules, it would read 98 grams on a balance. Sodium chloride, now that is a formula unit because I have a metal and a nonmetal. That's the name we use for that because it's not a molecule. Molecules contain nonmetals only. So it's a formula unit. So the molar mass of NaCl, so if I have 1 mole of sodium chloride, of course I have 1 mole of sodium and 1 mole of chloride. Each sodium is 22.99 Gs. Each chloride is 35.45. So 22.99 plus 35.45, 58.44 grams per every mole of NaCl. Here is also another formula unit because I have metals and nonmetals. So if I was figuring out the molar mass of sodium sulfate, of course, know for every 1 mole of this, there's 2 moles of sodium, 1 mole of sulfur, and 4 moles of oxygen. So 2 times 22.99, 1 times 32.07, and 4 times 16. So that's going to give me 45.98, 32.07, So 64. Notice I'm only going 2 decimal places here. That's all you need to do. 142.05 grams per mole of sodium sulfate. So that is how we do that. That's how we figure out the molar mass of larger elements, compounds, formula units, etc. All right, so we look at the next page. We'll look at a conversion. Now, you would have been given a blue sheet that looks like this, and we're only concerned about this part, going from mass in grams to moles. So we can follow this schematic, or we can follow a dimensional analysis. Either one is fine here. So it says here, calculate calculations involving molar mass. So chemists routinely use mass to measure the quantity of a chemical needed for investigation. As such, chemists need a convenient way to determine the amount of moles of a given substance if we know what it is in grams. As you'll see, molar mass is the quantity that relates the two. So over here we can see that molar mass, 1 mole is how many grams for molar mass, or molar mass is how many moles. So converting mass to moles is seen in the above figure. To convert mass to moles, so going from grams to moles, we of course are going to be using this setup. So going from here to here, 1 mole over the molar mass. Because as we'll see, the correct unit will cancel and I'll be left with the other unit. So if you look over here, according to the manufacturer, a typical can of soda contains 40 grams of sucrose. Calculate the number of moles. So we were given grams. We're asked to find moles. So if I look here, I'm starting here and I'm going to here. So we use this convert whatever. So if we figure out the direction we're going, use that conversion that we're going through. So of course we're going to have to figure out the molar mass in order to move on from here. And since we're dealing with sucrose here, we're going to have to figure out the molar mass of that. So the molar mass of C12H22O11. So we have, for every 1 mole, we have 12 moles of carbon, 22 moles of H, and 11 moles of O. So carbon is 12.01, hydrogen is 1.01, and oxygen is 16. So continuing on with that, 144.12, 12 times 1.01 is 22.12, and then 176.00. So that's going to give us 342.34 grams per every mole. So that's the molar mass of sucrose. So we're going to start off with what we're given because we're going from grams to moles. So 40.0 grams. And it doesn't hurt to write out the identity of what we're talking about here. This will come into play later on. And if we can get in the habit now of doing it, that'd be good. Now, molar mass. So we can state it like this, 342.34 grams per mole. Another way we could state it is as a ratio. 342.34 grams represents a mole. And 1 mole represents 342.34 grams. So we really have 3 ways we can represent that. To figure out which way we need to use it, though, you can see here we need to end up with moles and cancel grams. So grams here, and end up with moles. C12H22O11. So I'm going to likely use this version right here. And that's the version that's recommended here in this little schematic that you have access to. 1 mole over the molar mass. 1 mole over the molar mass. So that tells us that we need to use this because if we look, grams and grams cancel, and I'll be left with moles. So 40 multiplied by 1 divided by 342 will give me 0.11682 moles of sucrose. And if I look at this amount of sig figs here, let's see. Don't use molar mass for sig fig determination. Use the original question. 1, 2, 3. So I need to have 1, 2, 3. So that's going to leave me with, keep the 1, keep the second one. The 6 is where I'm going to end up, but the next digit is 8. So that means bump that up by 1. So C12, H22, O11. There we go. That's how we do it. Okay, we have one more example to do. We'll do it in the next video, and it'll be vice versa. Instead of going from mass to moles, we'll go from moles to mass. All right, we'll see you again.